Project Hail Mary, best-selling science fiction novel and now Ryan Gosling blockbuster, has been praised extensively for its scientific rigor. But what if I told you there was a big lie at the heart of the story? That's right, I saw something everyone else was enjoying, and I decided to find a hole in it. I have a problem. Now, I love this story. I read it years ago, and I recently listened to the audiobook with my wife. It's funny, it's creative, it's hopeful, and Rocky's the best. The book is filled with all sorts of wild speculations about alien biology, chemistry, and physics, and I love every second of it. Oh, alien chemists discovered a way to turn xenon into transparent sheets stronger than titanium? Seems unlikely, but we learn new things about chemistry all the time, so maybe it's possible. My complaint is about something else entirely, something beyond the realm of speculation. But before we go any further, spoiler alert. See, the story centers around this little guy. Meet Astrophage. Astrophage are microorganisms that come from space. Space germs, if you will. And these space germs have a number of unique properties that, when taken to their logical conclusion, allow for the violation of the second law of thermodynamics and the creation of perpetual motion machines. Something which is a big physics no-no. The first property you are likely to notice, Astrophage are black. Pitch black. They absorb all light they come into contact with, like little black holes. Second, they are hot. Way hotter than life on Earth. They're 205 degrees Fahrenheit, or 96 degrees Celsius using normal person units. Even weirder, they maintain this temperature no matter what. When they are exposed to heat, rather than warming up past this temperature, they store the extra energy directly as mass, following the equation E equals mc squared, or mc. This means that they can store an absurd amount of energy for organisms that are so small. Astrophages live in outer space. They need carbon dioxide to reproduce, so they've developed a neat little trick for getting it. When an astrophage sees the spectral signature of carbon dioxide on a nearby planet, it propels itself towards that planet by emitting photons out of its back end. Essentially, astrophages fart light. This is how they release all of the mass energy in their little spherical bodies. It is the combination of these properties that make astrophages a threat to humanity. When the sun gets infected by them, they multiply exponentially like bacteria in a petri dish. Their growth threatens to dim the sun and send the world into an ice age. Not even a good ice age, like Ice Age 1. More like Ice Age Collision Course, where they run out of ideas and they're sending the squirrel to space for some reason. To avoid this apocalypse, the best and brightest of humanity come together and devise Project Hail Mary, a spaceship sent to explore a nearby star system which is immune to astrophage and discover the secret to defeating it. The story is set in the near future, so how do they get spaceships capable of traveling between the stars? Well, it's easy when you have astrophage. That's right, the same properties that make it a threat to our world make it incredible rocket fuel. Humanity begins harvesting astrophage on an incredible scale to fuel the Hail Mary and save the world. While on his mission to understand astrophage, our hero, Ryland Grace, meets an alien named Rocky, a 5-appendaged rock spider from the planet Arid. His planet is also threatened by astrophage, so the two of them team up to do science, understand astrophage, and save both of their worlds. I know what you're thinking. This story sounds awesome. What's the issue? How do astrophage break the second law of thermodynamics? Well, with all the background out of the way, it's finally time for me to explain. Let's go to the whiteboard. I want you to imagine that we are on the planet Arid. The book describes Arid as being much closer to its star than Earth is, so its surface temperature is said to be about 410 degrees Fahrenheit, or 210 degrees Celsius. That's more a pressure cooker than planet. Stepping onto the surface will bake us into a stew, so we will be confined to specially cooled compartments. Let's say we enlist our Iridian friends to make us 2 identical, heavily insulated boxes. Each of these boxes contain normal Iridian air at 210 degrees Celsius. If we place astrophage in one of them, something interesting happens. Astrophage is always 96 degrees Celsius, no matter what. The heat flows from hot to cold, out of the box into the astrophage. Eventually, the entire inside of the box will drop down to 96 degrees Celsius, the same temperature as the astrophage. The extra thermal energy that was in the box gets converted into astrophage mass energy. And if we then transfer this astrophage to the neighboring box and show it the spectral signature of carbon, it will emit all of the energy it stored in the first box as photons. These photons ultimately get converted to heat and raise the temperature in the second box up to 324 degrees Celsius. It took 114 degrees worth of energy from the first box, so it gives 114 degrees worth of energy to the second. The chain is simple. Astrophage absorbs energy in the first box and releases it in the second. Now there is a temperature differential between the two boxes. Anytime you have a temperature differential, you can do work. What I have here is a Stirling engine. It is designed to tap into the temperature difference between its top and bottom plate. So if you place it on top of a hot coffee mug, the temperature difference between the bottom plate touching the mug and the top plate touching the room temperature air drives the turning of the engine. If you want it to turn faster, you can put an ice cube on the top plate to increase the temperature difference. Likewise, if the Iridians attach a Stirling engine between the two boxes, they can draw useful work out of that temperature difference. Given enough time, both boxes would reach equilibrium back at 210 degrees Celsius. To get more work, we simply repeat the process. Use the same astrophage to cool the first box, transfer them to the second, activate them to release their stored energy, repeat this again and again, each time drawing useful work out of it. Congratulations, folks! We just invented perpetual motion. Or I guess the Iridians did. They're doing all the work. Specifically, this is called a perpetual motion machine of the second kind. The second kind refers to the fact that it is not so much creating energy as it is causing energy to spontaneously flow from the cold sink to the hot sink. This violates the second law of thermodynamics, which says, among other things, that heat must spontaneously flow from hot to cold. There's a reason why putting ice cubes in water makes the water colder. Heat flows from the warm water into the ice cubes. The total energy of the system doesn't change, since the energy in the water is simply traveling into the ice cubes, but the entropy of the system does increase. This is to say that the energy in the system gets more evenly spread out, or lower in quality. Ice cubes melt, hot tea cools, stars die. Entropy always increases. This is a universal relationship. The fact that Astrophage violates it is not merely speculation. It is proof that such organisms could not exist. You don't get to be an outlaw when physics is the sheriff. Astute viewers might be wondering, don't freezers, air conditioners, and heat pumps do precisely what I am describing? Create temperature differences between the air inside your freezer and the air in your house, or between the air in your house and the air outside? Why doesn't that violate the second law? And it's true. Heat pumps do separate hot from cold, but they have to expend energy to do so. You have some very high quality energy coming from the outlet. You are using that high quality energy to create a low quality thermal difference. If you were to take a Stirling engine like before and connect one plate to the inside of your freezer and the other plate to the outside, you could never generate enough energy to run the freezer. This means the second law remains intact and you don't have a perpetual motion machine. Astrophage, on the other hand, do create this temperature difference spontaneously without expending any energy, and therefore do allow for perpetual motion. I've heard some people claim that all life violates the second law to some degree. The problem, of course, is that no, it doesn't. All life forms work by degrading their energy sources. Plants degrade photons coming from the sun. Humans degrade plant sugars in our stomach. No life breaks the second law. No life can break the second law. It is against the rules. Now, gentle viewer, I know what you're getting ready to type in the comments section. It's fiction, bro. Who cares? And frankly, I agree. I think everyone should go see this movie if they can. They'll probably have a great time and get to witness the best human-alien friendship since E.T. That is the core of this story. It is unreasonable to worry about weird physics edge cases of alien biology while chomping down on popcorn. That being said, thermodynamics is interesting in its own right. Understanding the real laws that govern the universe doesn't need to take away from Project Hail Mary, and it should enrich your understanding and appreciation of our weird little world. If you guys enjoyed this video, be sure to give it a like. This is my first real attempt at producing science content, so be sure to let me know your thoughts in the comments section. Thank you guys all for watching. Amaze, amaze, amaze.